All right, we're online. So, welcome to Lunchaytics 3 in Calgary. The last one of the season. The theme today is data visualization and information design. And our first speaker is the co-founder of Dark Horse Analytics, the man himself, Joey Cherdarchuk. He's going to be talking about Clever Hands.
Yeah.
Sure.
All right. I'll try this for a bit. So, being a talk about data visualization, I thought I would start us off talking about a man with a beard and his horse. That right there is my notes. Where are my notes? All right, we're going to be winging this one without notes. Good thing I wrote it on the way here, so it should be pretty fresh. So this guy's name is Wilhelm van Oosten, and he thought that we didn't understand animals well enough and that they had more cognitive abilities than we even knew. And so he tried to teach a cat math, and then he tried to teach a bear math. I don't know where he got his bear from, but he tried, and neither of them seemed too interested in it. But then he came across Clever Hands here. That's the big horse you see in the background. And Clever Hands showed a bit of aptitude for mathematics. I'm not sure if that's Wilhelm or a tutor that he hired for his horse there, but this is him teaching him some math. And what would happen is he'd ask him a math question like, what's the square root of 9? And Clever Hands over there would tap his hoof 1, 2, 3 times. And everybody's like, wow, this guy knows math. And then they'd ask him, what's 16 divided by 4? And Clever Hands would tap his foot 4 times. And they're like, this horse is amazing. It knows how to do math. And so, this being in Germany, the German Education Council got together and they're like, we got to make sure this horse really knows his math, that somebody's not trying to pull something over on us. So they put together the Hans Commission, an entire commission devoted to figuring out whether Hans knew his math. And at the end of this commission, some of the things they did is they tested whether it worked just with Hans's owner or if it would work with strangers asking Hans the questions. And sure enough, when strangers asked the questions, Hans still got the answers right. And so the commission came to the conclusion that Hans must just know his math. But there was a psychologist who wasn't quite convinced. And so he did a little further digging. And what he actually found out was something much more interesting was happening. Hans didn't actually know math. Hans could read the facial expressions and the subtle emotional cues of his audience, and he knew when they were expecting him to stop tapping his hoof and tell him. And he did that just by looking at them. He found it out because he put people far away or hid the people, and Hans didn't know his math anymore. So, and here's Hans entertaining a huge audience. So why did I tell you that story? Mainly because I like it. But what we have here is a case where we think the horse does one thing, but it actually does something much more powerful. And a lot of times, I think with data visualization, what we have is we think it does one thing for us, which is it just turns numbers into pictures. But I think it does a lot more, and I want to talk about some of those other more subtle things that data visualization can do. But first, I think a lot of times what we see when we see data visualization is what I would call data decoration. So somebody went out and they got some numbers on some cars. They put those numbers together in a nice tower infographic format, and they prettied up their numbers. But honestly, this visual just kind of gets in the way of the information. None of you is looking at that and going, oh yeah, Mercedes is the best. you just can't see it. It's all obscured by all the decoration they've put around it. And you actually have to read the little numbers up at the top in order to try and figure it out. So instead of decorating our data, what should we be looking to do with it? Well, I think one thing that data visualization does really well, other than just show you the numbers, is it humanizes the data. So this is a visualization put together by a company called Periscopic. And what it does is you see an arc, and then you find out that that individual arc represents a person. And then there's another person. And then a few more people. Each of these people killed by guns. Their lives ended short. And then you start to see the accumulation of all those lives as they come together here. And eventually you start wondering, when is this going to stop? When are we going to see the end of all these people being killed? Which is exactly the purpose of the visualization. When does this stop? That's that humanity that is brought into the visualization by introducing those points. I think that's something that we need to consider when we're building our visualizations. How do we make this more than just numbers on a page? Because if I come to you and I say 11,000 people were killed, that's not nearly as powerful as seeing that impact on individual lives. This is another one done by the New York Times. What we see here is Black men and white men who grew up rich, and we are watching them progress into their adulthood and where they end up. And what you'll see is considerably more of the blue dots, which represent Black men, end up down at the bottom here than white dots. And when this is actually just 10 numbers. So these 10 numbers at the end is just 10 percentages. But somebody's taken the time to make you see those not just as 10 percentages, but as actual individual lives. And that all of these people started at the same income bracket. But because they grew up Black in America, considerably more of them ended up poor in the end. And you see that a bit of the process there, but they're individual people, like bringing that humanity into the data. And when my boy, he's 7, was watching this, he's actually rooting for the little blue dots. He's like, come on, blue, come on, you can make it, right? It made these things real for him. Another thing that I think data visualization can do is it increases engagement. So here's the correlation game. Now, there's a few things more dull than a scatter plot of correlations. Somebody went through and they made a game, and you can go and I think I might have to click. You can put your guess in for what the correlation is there, what you guys guess. Oh, I was off by more than 10. And so I lost a life. Oh, I got that one right. No lives lost. 6.5. Dead on the money. I gained a life back. Like by adding this bit of gamification to it, we increased our engagement. I played this probably for an hour one day. I got really good at identifying these correlations. Visualization, you can actually bring people into the audience, bring your audience in on something that you might consider boring or dull or trivial, and actually have them spend time with it and learn something from it. There's sound effects for this that are like 8-bit Nintendo sound effects. You really should play it. Just search correlation game on your Google and it'll come up. Here's another one. It's a visualization done by a guy named Nathan Yao. He runs a blog called Flowing Data. And this looks at the ages that people have different occupations at. And by putting it in this rather intriguing format, it encourages you to actually look at this data, because I honestly don't much care about what the occupations are of different people in America and the ages of those. I would never have thought to be interested in this. But by putting it in this format, I'm instantly wondering about these things. And you can see things like, oh, there's not many electrical engineers who are under 20. It takes a while to get your degree, and then it grows up. Counselors, pretty flat across the board. So you get a sense of how the dynamics change across age for these different occupations. And that's something you may not have even cared to know about beforehand, but it makes you care. And the last thing I'd like to mention that it does is it invites investigation. And for this, I'm going to have to swap over. So this is a visualization that we made for the government of Alberta, which got released, I don't know, 2 months ago, 3 months ago. I'm going to skip over the tutorial. But this is a visualization of drinking water. Farmers get their drinking water tested. They send the results into the government. And the government has this huge database of data and eventually thought maybe we should do something with that the public can see. And with this data, we can look at things like total dissolved solids, which I like to think of as floaty things in your water. And we can say, well, how does that work? Well, let's filter for just the low total dissolved solids in your water. And then we can drag that across, and we can watch on the map there as the water flows from the mountains out east. It gets more and more floaty things in it, which makes a lot of sense. But you can actually see those geographic patterns as I moved here, because we've made it interactive. And so because it's interactive, I start to look at other things like, oh, there's a correlation between conductivity and total dissolved solids. As I drag total dissolved solids up, I see conductivity moving up. And that's really intriguing, and it makes a lot of sense. The more stuff there is in your water, the more conductive it is. Then you also see things like, you look at potassium down at the bottom there. It starts off high when there's low total dissolved solids. And then this sort of bimodal bump shows up when we get into the middle. And then it continues to the right. And that makes you wonder, why does that happen? And maybe you need to go and download this data and do a little bit more investigation, a little bit more digging. So by providing that interactivity and providing it in a way that's visual, you get people engaged in your data and interested in the details of your data where they might not have been before. That's also cool because you can zoom right in to your favorite town or location. So where Dan grew up, Tasquin, Wataska Win, which was Wataska I Win.
Still at the end, it will not complete.
There we go. And we can see that over here where Dan grew up, the water's really dirty. Other areas, much cleaner. So, and it doesn't have to be large, complex data sets where visualization can invite investigation. We can also look at something simple like a mortgage calculator. And if you do a mortgage calculator right, people start to ask questions. So for me, my question is usually, how long is it going to take before I've paid off my mortgage? And so if I'm borrowing $250,000 and I'm making monthly payments of $1,500 or $1,000, I will never pay off my mortgage. Let's scroll this down. So I can begin to see as I move across, the more I spend, obviously, the less it takes. But I can see the impact of different changes to that at $1,700. But what if the interest rates are lower? I'm able to lock in at a lower rate. How does that change things? And I can see just how long it's going to take. And because it's interactive, I can explore this. And if I'm starting out and asking, what are my, how much can I afford? I can switch those variables around and say, well, how much am I willing to pay monthly? And what if the interest rates are much higher? And I hope to pay it down in a much more reasonable time frame. Well, I can only afford $145,000 if that's my budget. And those things are answered quickly with this kind of visualization, which is really rather simple. So it's a short talk. Oh, gotta swap back. Do you know how to get back, Craig?
I think that was it.
Oh, there we go.
You're just also there. You're there.
There we are. All right, so quick talk, but good interactive data viz doesn't just decorate your data. Good interactive data viz will humanize your data. It will increase engagement. You look for ways to draw people in, and it invites investigation. Just like Hans the horse.
Time for one question. Or not.
Sorry,
One question.
did you use Open Library for those visualization?
So did we use an open library
Yeah.
for the
What
visualization?
did you use in terms of the technology?
In the technology,
Yeah.
we use a library called D3.
Yeah.
It is open source, and yeah, so that sort of thing could be created by anybody.
And out of curiosity, how long did it take to build that Alberta website?
The Alberta website, the initial one, we did, I think it was over 4 or 5 months. And then we've since done a number of upgrades, and there's actually, if you go to athan.alberta.ca, there is 4 or 5 other visualizations that we contributed to there.
Thank you.
Yes.
How do you decide when you're visualizing something, the trade-off on the audience? So someone like, if you're building something for dance, let's say, and it's a deep data set, do you have an idea of where you're going with that first, or do you have a more base approach? Like, okay, I want someone who has no idea what this data is. Where's that trade-off? Because I find I wrestle with that a lot.
Right. So just for anybody who didn't hear, the question was, how do you balance the trade-off in terms of who's the audience that you're targeting, and how do you decide how much they need to know? And I think you've already identified one of the key things, which is you have to figure out who the audience you're targeting is. And so in a lot of cases in the business environment, the audience you're targeting is going to be very familiar with the subject matter. And so you don't want to spend a bunch of time simplifying a process that's really well known. But if you're developing something for the public, they have a whole bunch of context that you need to bring to bear, and you may need to simplify in order to get it comprehensible for them. I think really paying attention to who the audience is number one. And then the second thing is, what's your purpose in the visualization? And is there a specific change that you're looking for people to have? Is there a specific insight that you're looking to get across? And making sure that your visualization supports that and doesn't distract from that. And I think distraction is something that you can easily fall into with visualization, because man, that looks cool. But does it really contribute to your point? So it's a more generic answer. I think it really does matter in the specific situation. There is no one right approach because every audience is different, and every time you're doing it for a different reason.
We have to cut off questions there. Go to our next speaker. Our next speaker is Milena Radzikowska. I might not have got the name quite right. She's going to be talking about the visual display of data, and she's a professor, associate professor at Mount Royal University. So, take it away.
Thank you. And I swear to God, I've never met that man before in my life. And any similarities between our talks are because this stuff is incredibly important, and we just wanted to say it twice. That was a really great. Some of your examples were in my slides. I pulled them by complete accident. So I'm a prof, and I conduct data visualization research, and our work tends to focus on experimental data visualization, and I teach in information design at Mount Royal. Fancy. So the strength of a graphical approach to the representation of data is that it enables us to see what otherwise would remain hidden. And I love this quote. I looked up quotes, fancy quotes on data visualization. This came up. I don't think that was the intent of it. But that idea that in the remnants of something can be something much more powerful. In the suggestions of a thing, of a graphical thing, can be something that is much more engaging. Here we have an example of a data set, and this one comes from the Washington Post, and it aggregates police shooting death statistics. And you have the names, the dates of the incident, the manner of death, whether the person who was shot was armed, their gender, their race, the city of the incident, etc. And when you look at these, this is a very powerful data set, and the numbers are very powerful. But it takes time, and it takes attention and imagination in order to really be able to engage with what this data set is attempting to tell us. Here you have an example of an interface that takes these numbers of a similar kind of data set, but it uses a graphical approach, and it takes a photograph of the person who had been shot and killed by the police, and uses that as the means to access the data. So we see each of the rows that existed in the previous data set, in this case, has been turned into that person's photograph. It's the actual photograph of the person. And depending on what you are interested in, you know, whether you're curious about race issues to do with police shooting sort of incidences, or if you're interested in gender issues or in age of some of these folks, you are able to search that out. And look for those patterns, and look for those kinds of relationships, and look for those things to reveal themselves to you. And through that graphical representation, we get that data, but we also get some suggestion around the complexity of a life that had been lived, that is no longer present. Now, whether we choose to use graphical objects that closely resemble the items in our collection, so the items in the data set, or not. So in the previous example, right, they used the actual photographs of the folks who were shot and killed by the police in order to represent or stand in for that data. Or whether you use something much more abstract. Each one of those kinds of choices comes with its own set of design challenges. So a quick reminder, for those of you who haven't studied Pierce in a while, is that for him, the visual display is displayed into three types of what we normally would call symbols. We would have You don't see the bottom one, but you have ones where the kind of images where you have close physical resemblance to what the image is meant to represent, and that's an icon, where you have some kind of a connection, so some suggestion, and that's an index. Often the example that's used here is smoke for fire, and that symbols are things that are learned. So there is no natural connection between the visual display and what it's meant to represent, but we have to learn. That's our alphabets and our numerical systems. Here's an example of an interface my colleagues and I designed many years ago now, and it's meant to help you, or be interested in, navigating Romeo and Juliet by Shakespeare. And in this case, each one of the speeches in Romeo and Juliet has been turned into a dot. So all the dots are the various speeches, and the way the interface works is that you can color code according to the different speakers. So in this case, you have Romeo, who's purple, and then you can add magnets. So you drop in a magnet for Romeo, and then you can drop a magnet in for love. And all of a sudden, you will see the speeches made by Romeo that are about love, and navigate the landscape of that play graphically this way. Now, there's no natural connection really between Shakespeare and dots, or Romeo and Juliet and dots. In this case, there's an arbitrary connection, and most of these decisions really were made for two reasons. One, sort of to experiment with this kind of display, but also two, to attempt to create a display where all of that data could be displayed at once. It could be played with all at once, all the speeches at once. Here's another one of our interfaces, and this one attempts to use like a slot machine, like at Vegas, right? You pull the lever and things align themselves to a slot. So in this case, you have the entirety of Gertrude Stein's The Making of Americans in the first slot, actually, and then repeated in each subsequent slot. And what is interesting about Gertrude Stein is that she plays a lot with repetition. And sometimes it's direct repetition within the novel, so the same phrase will be repeated over and over and over again within different contexts. And sometimes it's repetition with slight adjustments, slight change. And scholars, digital humanities scholars, are interested in that kind of exploration of text. So in this case, you are able to type in a phrase or select a phrase within the text. And then the idea is that the display will align itself. So the text will align itself to the slot, finding each instance of that repetition. So here, the idea is that you literally have the entirety of the novel in microtext. It's the actual novel. So there's a one-to-one relationship between what is being displayed and what we are seeing. If you zoomed in here, you could see, this broke my laptop at the time, it was back in 2006, you could see the actual text. So based on our work, my colleagues and I have done quite a bit of work in data visualization of all kinds, from word counts, as you saw, of 18th century novels, to I'll show you a project that we did with Syncrude Oil on decision support. And based on all of this work, now we argue the following. First, that every designed object holds some kind of argument, right? That is essentially positional. That when you make a decision, you are choosing a position on that subject matter. And that basically means that every design decision is political, right? It has a politic, whether it's intended or not, that politic is intended or not. That every design contributes to human knowledge, that every design is significant, and every design decision is significant because of that. And again, that's independent of intention, right? You might have made a design decision thinking, as our speaker was, I think, greatly pointing out previously, you might have made an aesthetic decision, and that might have not been a great decision, right? Because it was a very narrow focused decision. But it was still a decision that is made and that contributes in some way, positively or negatively, within the landscape of that subject matter and within the landscape of design. And then third, the designed artifacts are complex agents that act upon the world, right? That the things that we design, once they leave our hands, will have unintended interactions with others. And whether that is today or a month from now or a year from now or a decade from now, these are kinds of interactions that we cannot anticipate. But, and this is outside of this presentation, I would argue we are still held responsible for. So, besides functional constraints and the engagement, again, really important considerations around engagement, around affect that we heard about previously, we must also consider what and who are we representing through our displays, what kind of visual relationships or associations we are establishing through our graphical choices, and what are the implications or consequences of those decisions. So take a look at this example. This is an example, again, I routinely Google, the data visualizations I need to know about, right? The best data visualizations. This is one of the ones that came up. And this one's really interesting because as a default, this is the screenshot of the default that came up when I launched the interface. So note this, we have a default of a Black male, and then we have what the interface is about, which is all the different potential causes of death. So the idea is that the age will scroll, and then you'll be able to see the statistics change on what would be the cause of death for these individuals. Now, it struck me as peculiar that these are pretty nasty ways to die. I mean, dying isn't great to begin with, right? But we've got here, endocrine issues, we have cancer, we have external causes of various kinds. I mean, these are pretty nasty ways to go, yet they are candy colored. Now, from a functional perspective, right, I can sort of imagine the designer sort of sitting there and going, I need to choose lots of different colors so that folks can differentiate one cause of death versus another. That is completely legit. That's an important consideration, right? But there's also a consequence to that kind of decision. And the consequence, I think, here is that this is a really lighthearted way to treat a fairly not lighthearted subject matter. Now, in this case, you might be familiar with this design, and it's the We Feel Fine. And in this case, so in the previous case, you saw a challenge around equating human life and ways of ending that life to something graphically that we would interpret as lighthearted, and that could be problematic. In this case, we see these very swirling dots, and each one of these represents a statement made by a person around their feelings. And in an environment where we have some devaluing, in a social cultural environment, current environment, where we have devaluing of certain lives over others, the fact that they're all treated the same, with the same weight and the same importance, becomes important, right? Becomes valuable, becomes a particular type of political statement. Here's an example. They're not quite aligned right, but here's an example of an interface that we designed for Syncrude. And this was an interesting case because they asked us, it was a graduate project, but they asked us to not use oil refinement as a case study, right, as the model to which we were designing, but to use ice cream manufacture instead. So all of our designs and design decisions were meant to demonstrate ice cream, while in fact we were talking about oil refinement. Now this in itself, again, is a political position, right? There's something quite different about ice cream and about oil refinement. And in Alberta, right, that is a particular type of position to take. And that within itself, again, will have consequences. Here's me. If you're interested in more of our work or in any of the examples, feel free to reach out.
Please remind we have time again for one question, maybe two. If not, you know where to get a hold of Milena, and that's at Mount Royal. Just while we're getting our next speaker set up, Jeff LaFrenz is his name. I believe this is him right here. We are going to, I just want to know, how many of you do data visualization kind of as part of your job? How many of you consume data visualizations as part of your job, your decision making? All right. How many of you are looking for a job in data visualization? Anyone? So a couple. All right. And how many of you are offering jobs in data visualization? Okay, look around, look around. Three, 4. And we'll see if the market clears by the end of today. Okay. All right. So here we are. Jeff LaFrenz is going to talk. He's with VisWorks, and he's going to talk about visual analytics for 3D structures. So we're moving to yet another dimension.
Everybody can probably hear me anyway, but I'll use the microphone. So yeah, my name's Jeff LaFrenz. I'm president of a company called VisWorks, and it's very fine. And we are a local Calgary-based company, a group of developers, designers, visionaries, and so forth that work on highly interactive visualizations. And we really deal with that interface between the human and the digital world, and the digital world and humans. The result of that is we work on a variety of technologies, from augmented virtual reality technologies to artificial intelligence technologies, high-end interactive visualizations. Actually, one of the people on our team on the UFC side of things, working with the National Energy Board, is here. So we do a variety of different projects. They're doing the designs. We're doing the implementations of that for the National Energy Board. And ultimately, we work with companies and organizations that have a need to better engage with their data, typically through interactive means. So we're not typically on static visualizations, we do interactive visualizations. What I'm going to show you is work that we do with Synovus and now with a number of other companies. And what I'll start with is giving you the actual business case that drove this particular development process. So a lot of the oil and gas companies in town here, when they build infrastructure for up north, they build it in a modular fashion. What they do is design their infrastructure so it can be chunked into pieces. They build those pieces in a factory, they ship them to site, and ideally they assemble them on site as well. However, what happens a little bit too frequently is that they don't assemble properly on site, because the as-built of whatever they built and the plan for what they were intending to build are not in sync with each other. And this can happen for a number of different reasons. But what essentially this can cause for a project like this is, first of all, if it's a major issue, they have to ship the whole module back to the factory and have it rebuilt, which means that it's tremendously costly to do that, and it also causes tremendous downtime in the project itself. But if it's even a minor problem, they have to ship a team to site and rework the module on site in order to create an interface between the two modules. In both cases, it's something that they don't want to have happen because it causes issues with the project. So what they were thinking about, and what we worked with them on, was to take a high-resolution scan of an existing physical module, and then overlay that scan on top of a CAD drawing for the module, and then using a visual interaction using augmented reality, actually walk around it and see where the differences are between the two of them. And one thing, because it's a broad audience here, maybe I'll give you a broad background on augmented versus virtual reality, because there's a lot of topics thrown around in this area. I'm not sure if everybody knows what they are. So virtual reality is the one that most people are familiar with, the one that's commonly in the gaming environment, which is put on a Oculus Rift or a Hive Pro, HTC Vive type of device, or Google Cardboard, or one of these kind of various devices, and essentially you block out the real world around you. Your visualization is now presented to you as completely artificial. It may have nothing to do with what the world is around you. Now, augmented reality is a similar base technology to that, but instead of blocking out the world around you, it drops augmented objects into the world around you. So now that could be a virtual chair, or there could be a virtual person sitting in that chair. To me, it would look like there's a person sitting there if I was wearing an augmented reality headset, but they could be in a different city altogether. They just look like they're actually sitting in that chair. And so it really enhances and adds things into the world around us. And it's one of the, if you look at kind of what the predictions are, if you like, for this technology, virtual reality right now is the biggest of the two technologies, and it's growing very rapidly, but it's very much focused on the entertainment industry, and it's just making inroads more recently into more industrial applications. Augmented reality is a newer technology in terms of its current deployment, but the predictions are that it's going to vastly overwhelm virtual reality and take over the marketplace because it has much more practical applications of it. when we can start overlaying virtual things into the physical world, we can do some amazing things with that. So this is the problem case. We worked with them to do that. Essentially, you can see here we're overlaying, the yellow is an overlay of the scanned image on top of the CAD drawing. And from a visual interaction perspective, this is data. It's just three-dimensional object data that we're working with here. So we created a full augmented reality interface that allowed them to walk up and around a physical module as if it was in the room with them, or virtual model that was physically with them. They're able to identify mismatches, and as a result of that, they're then able to measure where the differences are between the two, and they're able to adjust the next module so it fits what's really on site versus what they thought was on site. And that was great, and that was a really neat project. We worked with them for quite a while developing these capabilities. But as we started looking into this in more detail and started going to root cause analysis around why does this kind of thing happen, we started realizing that a lot of the reason behind this actually comes out of the design process itself. And one of the challenges when you're doing design is engaging all the people that need to be engaged to make sure the design you do is going to meet the needs of the people that are going to be using it. And in this particular case, one of the elements that was missing a little bit was the constructability side of it. Because once you get it to the factory to build it, they're going to try and build it to the drawings you gave them. But if the way you designed it isn't easy to manufacture, they're going to make adjustments as they do the manufacturing. And those adjustments can have consequences on the interfacing with the next module. And so what we started looking at is, okay, although this is a great extreme business case, the real opportunity here is to go back in time, so to speak, to the design phase and actually look at the engineering design process itself and see if we can improve that. And that's what we did. So we went back after we did our root cause analysis. Actually, the other area, of course, is construction errors themselves. So people actually on site making mistakes. That's the other major source of errors for why these things are out of sync. And first of all, for those of you who are not familiar with it, what is a classic engineering design review? This is where we thought was the best place to go into it. And a classical engineering design review is somewhat like this: large group of people, large display. You're displaying 3D objects on a 2D display, and everybody's trying to understand what the heck they're looking at. And one of the challenges ultimately around this is there's no intuitive sense of scale when you're doing this. I don't know how big anything is unless I put an artificial scale of some sort into the picture. Maybe I drop an artificial human being in there to get a sense of how big is that thing, or I drop a ruler in to measure distances between things. This is the visual interaction that you get with these kind of environments that allow you to get a sense of scale, but it's not intuitive, which means because it's not intuitive, it's easy to miss things. And it also means that you have to have a very rigorous and long drawn out process for doing engineering review to ensure you get as many of the things as you can. But ultimately, they still end up with issues in the design that are not captured appropriately. So just to give you a context for this in terms of what the scale of this issue is, if you look globally at the annual spend on non-residential construction, it's about $3 trillion a year. You think of that, that's a massive amount. And if you look at the stats for this, up to 30% of those costs are due to rework. Issues that should have either been caught in the design or issues in the actual manufacturing process of whatever the building they're putting together. That's a massive amount. That's $900 billion of potential cost savings that can happen globally if you do the design better in the first place. So it's a massive issue globally to try and deal with. And it goes beyond just the construction costs, because if you really look at this, if you don't address the issues of usability as well during the design phase, you can bake into your construction things that are going to have an impact with the entire life of the facility. Inefficiencies in operations or maintenance or the ability to train people appropriately, or safety issues that are now you have to have massive workarounds for a safety issue, or a massive cost of trying to readjust the structure in order to deal with the safety issue. So the design is kind of the highest leverage point of making sure that this building not only is going to cost less to build in the first place, but it's going to have the lowest cost long-term in terms of efficiency of the design itself. And there are existing solutions. Of course, this is not a new problem. We started out in blueprint days, and this is a thing that we've been doing for millennia probably in some various forms. Going into CAD drawings, of course, 3D tools of various sorts, and now 3D printing has become a very big thing. So we're printing out these little 3D printed models of these. And that's all great, and they all help a bit with that. But again, even in a 3D printed model, you don't have a true sense of scale because they're not typically printed to scale. Although this is actually a technology that is available now, and there are countries that are starting to print 3D buildings, actual buildings, using 3D printers. So stay tuned where that's going. But if we look at this, this is not a new problem. But the other side of this is that projects are trying to get done faster. The projects are getting more and more complex, and the timelines to try and do them are getting shorter and shorter. And so essentially the tools that we have available to do this are running out of gas. They're running into the limitations, and particularly this shows up in the design review process itself. Because the design review process, again, is typically looking at 3D on a 2D screen and trying to imagine what it looks like, whereas true 3D visualization allows you a more intuitive engagement with it and uses this processor here rather than trying to imagine it, you can see it. So that's what we did. So we created this tool, and we took it from the process where we had it originally, we brought it into the engineering design review process, and now we allow groups of people to walk around in a virtual 3D environment within any room you want to put it in, and see the objects as if they were in the room with them, bend down, look at it from whatever perspective you need to look at it from. Can I get a wrench in there? Can I remove that pump? Can I get into that point? All those kind of things you can now do as a natural human interaction versus trying to imagine it on a screen that isn't designed for that. And in fact, when we showed this off within Synovus, the company we were partnering with to develop this originally, to one of their safety engineers, he looked at a module that had already gone through the design review process, had already been built, had already been shipped to site, was already in use. And he went, oops. And he looked at it within a couple of minutes, he recognized a flaw in their design, and he said, I would not have approved this if I'd seen it this way. And it's that natural human ability to see 3D and work within 3D that we provide in this kind of a visual interaction space that you just don't get out of trying to do 3D on a 2D screen. So what we've ended up with as a result of this is recognizing this kind of thing applies not just in the design review phase, where we started, but it actually is across the whole life cycle of a facility. Everything from the early concept phase, where you're trying to imagine what are we going to build and what are the different options for things we want to build, even before you even sold this. So you're trying to sell an opportunity to somebody, you can show them different concepts and get them to walk through it in a way that's more realistic and more intuitive. Through to construction, where we can now drop augmented reality into the physical world and allow people to see how's that staircase going to go as I'm building it out. To the area where now we can bring in these augmented reality models and virtual reality models into training and operations capabilities to really change the way that people engage in the 3D world and bring in the real and the artificial together. And we're actually already getting involved in the turnarounds and renovation space. We're working now with Mercedes-Benz. They're doing a $4 billion renovation of a facility in Alabama, one of the major manufacturing facilities for automotive. And they bring in battery technologies and all sorts of things like that. But the problem they have is they have a facility that's been around for a long period of time. And efficiency is key to their operations. So as they're bringing in a new design, as they're bringing in these new facilities, they have to blend them into the existing facility in the most optimal way. But those facilities have evolved since they were originally born to where they are today. And so they have no necessarily existing truth gold standard of exactly what's in their facility. And so they're faced with a problem. They can either go in and scan everything in high resolution to try and capture a 3D model of it, and then they have to identify everything that they've scanned and kind of basically work their way back to a CAD model from a scan, which can be done. Very expensive, but it can certainly be done. But instead, what they want to do and what they're using our technology for is to design new areas, new conveyor belt systems and robotics and all the rest of it, and then bring those augmented reality objects into the actual plant and drop them in the actual plant and see how they're going to line up with what's already in place. So complete physical interaction with a physical space, but using augmented reality objects. And this is where visual analytics in this space is really going. Now that you can start overlaying augmented information onto the physical world, you can now imagine a future in which we're literally, as we're walking around a facility, we see the facility tell us what we're looking at. tell us the status of the various things that we're envisioning. Give us all the detailed data that's coming out of IoT sensors that are deployed throughout your facility, contextualize it in a way that's meaningful to myself and my role within that location, and provide that data to me in an intuitive way that doesn't require me to go to a control center or look it up through some interface of some sort. It's just overlaid in the way that's most sensible for me to actually engage with. Now, the hardware's not quite ready there to support this kind of thing, but it's getting to the point where it could be available, and so that's where this technology is evolving, for sure. And, this comes back to really, using this processor better. As human beings, we have an amazing cognitive ability to deal with visual information, and so the better we can present that data in ways that's more natural to the way that we visually interact with the world around us, the easier it is for us to understand it, and the easier it is for us to actually make decisions around that. That's me. Thank you.
Thanks, Jeff. Time for questions? Go ahead.
Sure.
I was just wondering what your precision and accuracy is like. Is it down to the inch, millimeter, or like centimeter when you do these?
It's somewhat device dependent. So the device we're using for the augmented reality is the Microsoft HoloLens, and that's certainly down to the sub-inch level. But there's tricks around how you make sure that precision stays there by using different kind of technology like marker technology to align the physical and the virtual together.
Can you actually measure the mismatches in your software? Or
Absolutely.
Is that just
Yeah, so in
one
fact, we
area?
brought in the capability to drop rulers in and actually measure things as in the augmented world, for sure.
Jeff, Phil Unger, Canadian. Good to see you again.
Yes.
Presentation. Quick question. Can you talk about your technology stack that you're using? Are you using something that's being driven by a Google or something along those lines, or is it more open source, or is it something that you guys have developed yourselves?
It's a mixture of a number of things. Ultimately, when you're dealing in augmented and virtual reality, however, you're dealing in a gaming environment. So in this particular case, we're using the Unity gaming engine. Is the underlying engine that actually allows us to fully interact with three-dimensional worlds. It's just a physical manifestation of these particular worlds. So it's using the gaming engine you'd use for any one of the games that you have out there. There's a number of them, but there's two main ones that are out there. There's the Unreal engine and the Unity engine. Unreal has a lot of benefits in other areas, but Unity tends to be a little bit lighter weight, and so it works better on devices like these that have a more restricted processing capacity. Yeah.
Is it Unity as in Kerbal-based program?
So Unity is a gaming environment, so it's a
Yeah, but
programming
is it
environment.
that C# library that was used to write
Uh,
Kerbal-based?
I'm not sure of that. I'm not a programmer myself, so I can't actually comment specifically on that. But there is a specific programming environment that works within the Unity that our developers are using for that.
All right. Well, thanks again.
Thank you.
It was a pleasure. And I want to give a shout out to our sponsors, Startup Calgary, for providing the space for this event and promoting it and allowing us to come together for this. And today's event was brought to us by Dark Horse Analytics. So thanks, Dark Horse. Again, if you'd like to participate, volunteer to help coordinate these for next season, come talk to me. And if you'd like to sponsor either a single event or a sequence of events, there are amazing benefits to sponsorship. And let me tell you about them face to face. Thank you very much.
Yeah, we'll give you some.